Welcome to basic partial fraction examples. So in this example, let's go ahead and evaluate the indefinite integral, which is the integral of 2x minus 3 as our numerator, all divided by x squared plus 5x plus 6 as our denominator, dx. So just note quickly that our denominator factors as x plus 2 times x plus 3. So we can rewrite this integral as the integral of 2x minus 3 over x plus 2 times x plus 3 dx. Now, if we were to split this fraction as a sum of fractions, it would make sense that our denominators would be x plus 2 and x plus 3. So again, if we were to split this as a sum of fractions, then the denominators, or the new denominators, should be factors and so what we are going to do is we are going to try writing 2x minus 3 over x plus 2 times x plus 3 as some fraction capital A over x plus 2 plus capital B over x plus 3. Right? These are the only denominators that we could use to then wind up with a common denominator of x plus 2 times x plus 3. So from here, one way we can go ahead and solve is just clear the denominators. So we're going to go ahead and clear the denominators by multiplying by x plus 2 times x plus 3. So we are looking at 2x minus 3 over x plus 2, x plus 3 being multiplied by x plus 2, x plus 3. And this should be equal to a over x plus 2 times x plus 2, x plus 3 plus b over x plus 3 times x plus 2, x plus 3. Of course, in our first fraction on the left-hand side, the x plus 2's and the x plus 3's cancel. On the right-hand side, for multiplying a, the x plus 2's cancel out, and for multiplying b, the x plus 3's cancel out. And so we wind up with 2x minus 3 is equal to a times x plus 3 plus b times x plus 2. You can solve this in various manners. One option is expanding and then matching coefficients, but you can also solve by picking sort of special values of x. So note, if we plug in x equal to -3, then we'll have a times 0, and so the a term will just cancel out. So we get 2 times -3 minus 3 is equal to a times 0 plus b times -3 plus 2 is -1. This gives us -6 minus 3 is -9 is equal to -b. And we get that b is equal to 9. Similarly, for x plus 2, if we plug in a -2, that will go to 0. So if we plug in x equals -2, then we get a b times 0 piece, and so that term disappears. And so we have 2 times -2 minus 3 is equal to a times -2 plus 3 is +1 plus b times 0. So we wind up with -7 is equal to a. So putting these together, we have that our 2x minus 3 over x plus 2x plus 3 is equal to -7 over x plus 2 plus 9 over x plus 3. So what this means then is that our integral of 2x minus 3 over x plus 2 times x plus 3 dx is the same thing as taking the integral of -7 over x plus 2 plus 9 over x plus 3 dx. Of course, we can then rewrite this as -7 times the integral of 1 over x plus 2 dx plus 9 times the integral of 1 over x plus 3 dx. These are just simple linear denominators. So this becomes -7 times the natural log of the absolute value of x plus 2 plus 9 times the natural log of the absolute value of x plus 3 plus c. So this enabled us to avoid having to use other tricks that we've seen, trig substitution types of things. Partial fractions can make rational functions much, much easier to integrate. So let's go ahead and do one more example. This time we'll evaluate the definite integral from 0 to 1 of, in the numerator, 5x plus 4, all over in the denominator, 2x cubed plus 5x squared minus 8x minus 20. So the first thing we're going to do is find an antiderivative. And to do that, we need to factor the denominator so that we can hopefully split it up. So we're going to go ahead and factor the denominator. So 2x cubed plus 5x squared minus 8x minus 20. We can factor using factor by grouping. So we're going to group the first two terms and the last two terms. 2x cubed plus 5x squared, we can factor out that x squared. We're left with 2x plus 5. Those last two terms, we can factor out a -4. We are left with a 2x plus 5 as well. Then this 2x plus 5 is now a common factor, can be pulled out front. So we wind up with 2x plus 5 times x squared minus 4. And then x squared minus 4 is a difference of squares. We have 2x plus 5 times x plus 2 times x minus 2. So we are looking at an integral of 5x plus 4 over 2x plus 5 times x plus 2 times x minus 2 dx. At this point, we are going to run partial fractions. So we have 5x plus 4 over 2x plus 5 times x plus 2 times x minus 2. This should be equal to some constant over 2x plus 5 plus a constant, so a constant a over 2x plus 5 plus b over x plus 2 plus c over x minus 2. If we clear the denominators, so if we multiply by 2x plus 5 times x plus 2 times x minus 2, then we get 5x plus 4 is equal to a times x plus 2 times x minus 2. Right? Only the 2x plus 5 cancels on that first term. Then we would have plus b times 2x plus 5 times x minus 2. And then plus c times 2x plus 5 times x plus 2. Note, if we plug in x equals -5/2, then the 2x plus 5 will be 2 times -5/2 plus 5 is 0. And so we wind up getting, we have 5 times -5/2 plus 4 is equal to a times -5/2 plus 2 times -5/2 minus 2. But then we would have plus b times 0 plus c times 0. So plugging in -5/2, that a term is the only one that doesn't go to 0. And we wind up getting 5 times -5/2 is -25/2 plus 8/2 is a -17/2 is equal to a times -5/2 plus 2 would be -1/2. -5/2 minus 2 would be -9/2. So we have -17/2 is equal to a times 9/4, or a is equal to a -34/9. Similarly, if we plug in x equals -2, that x plus 2 term will go to 0, and the a and c terms will cancel out. So we'll go for x equals -2 next. So if we plug in x equals -2, then we have 5 times -2 plus 4 is equal to a times 0 plus b times, we will have a 2x plus 5 and an x minus 2. So 2 times negative 2 plus 5 times a negative 2 minus 2, and then a plus c times 0. This becomes negative 6 is equal to b times 1 times negative 4, or negative 6 is equal to negative 4b, and we get that b is equal to 3/2. Finally, to get that c term to be the remaining one, both the a and b terms have an x minus 2. So if we plug in x equals positive 2, we'll just be left with a c term. So if we plug in x equals positive 2, we have 5 times positive 2 plus 4 is equal to a times 0 plus b times 0 plus c times, we have a 2x plus 5 and an x plus 2. So we would have 2 times 2 plus 5 and then a 2 plus 2. So this becomes 14 is equal to c times 9 times 4, or 14 is 36c. And we get that c is equal to 7/18. So at this point, we have that our 5x plus 4 over 2x plus 5 times x plus 2 times x minus 2 is equal to, I'm just checking I have my order correct. A was negative 34/9 over 2x plus 5 plus b was 3/2 over x plus 2 plus c is 7/18 over x minus 2. So we have our integral of 5x plus 4 over 2x plus 5 times x plus 2 times x minus 2 dx is equal to the integral of negative 34/9 over 2x plus 5 plus 3/2 over x plus 2 plus 7/18 over x minus 2 dx. We can, of course, split that as negative 34/9 times the integral of 1 over 2x plus 5 dx plus 3/2 times the integral of 1 over x plus 2 dx plus 7/18 times the integral of 1 over x minus 2 dx. This becomes negative 34/9 times the natural log of 2x plus 5, but we're going to have a times 1/2 out front to counteract that 2x. So negative 34/9 times 1/2.
I found this on the web.
Sorry about that. I somehow hit Siri. All right. So we have negative 34/9 times 1/2 times the natural log . Sorry, my pen's not working. All right, trying again. So we have negative 34/9 times 1/2 times the natural log of the absolute value of 2x plus 5. Then we would have plus 3/2 times the natural log of the absolute value of x plus 2. And then finally, plus 7/18 times the natural log of the absolute value of x minus 2. And of course, our plus c. So all that work to find the antiderivative or find the antiderivatives. Now we need to find our definite integral. Scrolling back up, our definite integral is from 0 to 1. So step 2 is to find the definite integral. We are looking at the definite integral from 0 to 1 of 5x plus 4 over 2x plus 5 times x plus 2 times x minus 2 dx. Note, the function is continuous on 0, 1. So note, the integrand is continuous on 0, 1. So the fundamental theorem of calculus does apply. And so we have that this is equal to our negative 17/9 times natural log of the absolute value of 2x plus 5 plus 3/2 times the natural log of the absolute value of x plus 2 plus 7/18 times the natural log of the absolute value of x minus 2, all evaluated at 0 and 1. So this is a negative 17/9 times the natural log of 7 plus 3/2 times the natural log of 3 plus 7/18 times the natural log of the absolute value of negative 1. So natural log of absolute value negative 1. We subtract off negative 17/9 times the natural log of 5 plus 3/2 times the natural log of 2 plus 7/18 times the natural log of absolute value of negative 2. And at this point, we can simplify or leave as is. Natural log of absolute value of negative 1 or natural log of 1 is just 0, so that one will go away. And then I'm just going to write simplify that. You could also plug it into a calculator. But so these are our basic cases where we just had linear factors in our denominator and none of the linear factors were repeated.